So good evening, everyone. Hope you're having a wonderful Wednesday evening. So my name is Alvin Chin. I am the chair of ACM Chicago. So thank you for coming to this evening to listen to our talk on DSP in the clouds. And we have our speaker, Teri Grossheim. And this is also being co-hosted by Mid-America Club IT Connect and IEEE Computer Society as well. Okay, so for those who may be coming from IEEE Computer Society Chicago, so IEEE, if you don't know, is like the sister chapter or so of IEEE. Sorry, of ACM, not IEEE, of ACM. And we basically do the same type of stuff. So we do meetings on software, hardware, computing. Actually, we do monthly as well. So we do a lot of joint events with ACM Chicago in this area. So I'm also the chair of IEEE Computer Society Chicago. We have actually our next particular meeting that will be next week, and I will mention about that later. Our vice chair is Gina Martinez. You can see our website. We're on social media. And if you missed any of our previous webinars, you can go to our YouTube link there. And of course, if you want to become an IEEE Computer Society member, there are many benefits like going to the conferences, getting discounts on if you want to get particular papers or so. You can go to the URL that's there. So just a bit of housekeeping rules. This meeting is being recorded, so you will receive a copy of this recording after the meeting is over. And also the slides will also be sent to you as well. Okay, a little bit about Mid-America Club IT Connect. So it's a group in the Mid-America Club. So it's a private club in the Aon building. So if you've been to the Aon building, it's located on the 80th floor. When we were actually in person, I believe our last event was actually held there last year. So I think it was in February or so before the pandemic happened or so. So we hope to resume hopefully in the fall when we have in-person back meetings that we can do it there. It's a great club, good panoramic views of the Chicago skyline. The chair is VJ. So VJ is on the call here. And I'm the vice chair. And if you want more information, you have the links there for Mid-America Club. So we thank you, Mid-America Club, for your support with these webinars. And of course, ACM Chicago. So the majority of you here are from the ACM Chicago Meetup. So for those who don't know ACM Chicago, we're the Chicago chapter of the Association for Computing Machinery. So we now do monthly meetings on topics dealing with computing. For example, we've done stuff on supercomputers. We have done stuff on vehicles, automated vehicles. We've done stuff on big data, machine learning, things like that. So like I said earlier, I'm the chair. Our vice chair is Mark Temkin, who's in the clouds there, looks like. And then we have Greg Newmark, who is the treasurer. Our website is chicagoacm.org. A lot of you have known about our meetup from our meetup page, so you can also follow there to get our latest when the next meetup will be and sign up. We're also on social media, so Facebook, Twitter, LinkedIn, and of course we also have a YouTube channel. So if you subscribe there, then you can get the latest recordings if you've missed them. And also as well, if you want to become an ACM member, you can also go to this link below. All right, so for IEEE Computer Society, we actually have our June meeting, which will be next Wednesday. But of course, this is also open to everybody else here too as well. So we actually have a distinguished lecturer from IEEE Computer Society. His name is Dan Shoemaker, and he is a professor at the University of Detroit Mercy. And he'll be talking about the secure sourcing of commercial off-the-shelf products with regards to supply chain. So an interesting talk. If you want to register for that, you can just go to that bit.ly URL that you see there. And I will also send the link for this too as well afterwards. And then I'll now turn it over to Mark, our vice chair, to talk about our next, and I believe it's our first ACM Chicago meeting that we've actually had in July. So Mark, go ahead and take it away.
Okay, so next month on July 21st, our topic is about you and your future in IT in careers, riding the rapids of change with Bruce Monty of Loyola University. Bruce will be our moderator, and we will have panelists and you, the audience, and we're all going to talk about how to stay relevant and adapting to change in technology and organizations, using social and professional networks, and when and if to make a total career change. So we're opening up the floor next month, and we want as many as can participate as possible. So make sure to sign up for this special July event where you're attending and participating in a rare open floor discussion. So that's next month, July 21st, same time.
So thanks, like I said, thanks, Mark. Thanks, Alvin. Thanks, everyone that is on the Zoom today. I'm really happy to be here. I love meetings like this and just talking about technology and what's relevant today. A topic near and dear to my heart is digital signal processing, or basically media engineering, really, and any applied technology when it comes to media engineering. And Mark and Alvin were looking for some topics, and we had, some repetition in the last few meetings. And I said, hey, let me talk about the cloud, because there hasn't really been many ACM meetings in the Chicago area that dealt with cloud computing. So they thought that DSP in the cloud would be a neat topic, and that's what I'm going to discuss today. These slides will also be available afterwards if you want a copy of the slides. Obviously, as Mark and Alvin mentioned, this is also being recorded. So a little bit about me. Mark gave a great brief intro. I'm not going to go down the list, but I've definitely held a few positions over the years in varying areas. As Mark mentioned, I got my start in technology through the recording world. I had an interest in electronics when I was a young person trying to navigate my career. I'd spent some time in the San Francisco Bay Area doing my undergraduate internships. Obviously, being exposed to Silicon Valley really opened my mind to the need to focus on a more technological forward trajectory in my career. Hence me continuing my education at Indiana University, Purdue University in Indianapolis, where I had a graduate assistantship. There I studied informatics in the mid-2000s, which at that time, artificial intelligence, data science, machine learning, it was very theoretical. It was not, in industry today, but it was really neat in that I was able to study it before seeing it put in motion with things like smartphones, wearables, cloud computing, and being part of the team that helped build Apple supply chain under Tim Cook when I was an Apple engineer at CDW in Chicago, starting in 2011 when he took over for Steve Jobs. So I've been able to do some really neat things and go to school at the same time, and I am really grateful for that. I've also taught as well in the evenings to help pay off my student loans magically at the Illinois Institute of Art Chicago. I was an audio in the audio production department. I was an adjunct professor for several years and was promoted in 2018. Obviously, with the pandemic and dealings with that institution, I've been applying for some teaching jobs here as well. Before joining the ACM, I was quite active in the Audio Engineering Society. I was actually quite active in the Chicago section for about 10 to 12 years. Hung out at Shure a lot. There's a lot of rich history of audio in Chicago, in addition to being active on a national level as well. So that's a little bit about my background. Feel free to find me on social media. I'm pretty engaged in those places if you want to chat with me afterwards. As far as an agenda, what I'd like to go through today is a brief introduction and history to digital signal processing. If you're not familiar with what it is, maybe it's my background as an educator to kind of set a baseline so everyone is somewhat familiar with the topic at hand. You might be a SME, you might not know anything, but I think a few slides just talking about what exactly digital signal processing is a good level set for the rest of my presentation. And then I'm going to talk a little bit about networking, and specifically what I'm going to discuss is software-defined networking, or SDN. That also holds a place near and dear to my heart that I'll get to later, and why that particular topic is very interesting to me as a technologist. The agenda, I talked about SDN, or software-defined networking, also a brief introduction in history. I'm going to discuss where digital signal processing is via cloud computing. It's still relatively nascent. However, all the mechanics are there. So I'm going to dive into some technical details about that. And then I'm going to go into cloud service providers and what they're doing right now with software-defined networking. And we'll talk a little bit about some applications of DSP as well. And then hopefully we'll have a little bit of time regarding Q&A. So digital signal processing, what is it exactly? It's a mathematical or computational representation of an analog signal. You can really think of it as an analog signal can represent anything from a piece of audio, sound, graphic, or video data. You might have heard the term sampling rate. If you've ever been exposed to this space. Basically what a sampling rate is the number of snapshots of an analog signal. And if you see the graphic to the right, the snapshots are notated by the dots on the x-axis, right? So if you can think about the solid black line is the analog signal, the dots are the snapshot. That's basically what's getting converted eventually into digital information, so it can be dealt with computationally. Another term you'd probably want to be knowledgeable about is bit depth. You can think of that as the amount of stored data represented by the y-axis. So if you think about, or have ever been exposed to the space, you might have seen something like 16-bit, 24-bit, right? So the more, the higher bit depth that you have, the more amount of stored data you're going to have in that piece of data when it comes to an analog signal. Some other important terms you're also going to want to be aware about is quantization. So basically, quantization can be almost thought about as the rounding of that snapshot number. You're basically taking a finite number and rounding it to, you can almost think of it as like, I wouldn't say it's almost like rounding it to a least common denominator or the closest variable. It's done in a way where it's going to be translated into a binary number, a 1 or a 0, right? So the graphic at the top is denoting what quantization is doing, or how that's translated into a quantized value. You can think of that, again, the analog signal is the dashed line, where the quantized information or the quantized representation in the top graphic is the zigzag solid line that you're seeing. And essentially, it's moving that piece of information to a rounded or a a clean number, so it can be, I'll say clean, I should say real number. I'm going through some more math classes right now as we speak. A real number in order to be denoted in a binary number form. So essentially that's how an analog signal becomes a digital signal. It can be a lot more complex than that. There's so much literature out there on this process, but for the sake of this presentation, I've sort of condensed it down to these 2 slides. So at least you kind of understand, like, how is my piece of sound being represented? How is my graphic being represented? How is my piece of video being represented in a computational form? So in this space as well, you'll read a lot about analog to digital or digital to analog converters, ADACs or DACs. You also see this when you're looking at cloud computing as well in this space. These are the devices that are essentially doing this process. You're going to find them in hardware form historically, but I'm going to talk about the software or the virtualized versions of these devices in cloud computing form. So moving on to networking. So when you think about digital signal processing and you're talking about digital assets in a hardware space, what does that look like? I talk a lot about from the sound or audio space because that's historically where I come from. Graphics, video work very similarly. You're going to find things like traditional computer networking. In these spaces, you're going to find, routers, firewalls, switches, your traditional, even wireless computing. You're going to find that in this space, right? You're going to find any of those topologies in this space as well. There are some specific ones that I'm going to mention just for like a historical context, because this space has historically been a hardware-driven environment, and now we're migrating towards that into a more software and virtualized environment. So this is just giving context to like where this came from. Talking about audio over IP, obviously it's been around for, it's not the newest technology. ISDN historically has been what audio over IP has looked like. Moving to 4G and 5G, we're looking into cellular and wireless. Elk Aloha is something that is, I found that is common now through 5G networks that's doing audio over IP, where you can actually collaborate if you have a 5G chipset in your device, which is kind of cool. With the consumerization of smartphones, tablets, that's obviously become more common. Audio over Ethernet, through the 2000s, CobraNet was sort of the standard in that regard. I don't say proprietary, is made by QSC, but it wasn't widely adopted. And now what you're seeing is Dante, which is the top photo. That is seemed to be more widely adopted and common in environments that you're doing more advanced processing of sound in different environments. Fiber channels also historically been used in these environments, and you're talking about, if you're thinking about advanced video and video and graphic applications, XANs were quite common, but obviously a lot of that is migrating to the cloud as well. So next, I want to talk a little bit about software-defined networking, or SDN. So why this holds a close place to my heart is that when I completed my graduate studies at IUPUI in Indianapolis, the global NOC of Internet 2, which is basically an academic software-defined network, was located in the building that you see up top. I spent a year in that building completing my my graduate work. At that time, it was very cutting edge. Things like data science, machine learning, and artificial intelligence were not in industry. Again, I had decided to pursue graduate studies after spending some time in the Bay Area, being exposed to Silicon Valley. Definitely motivated me to learn more, and I can't speak enough to my time spent in that building and learning about software-defined networking. The OpenFlow protocol, which you'll often see associated with software-defined networking was co-created by Stanford and Indiana University. And without I don't say without it, but OpenFlow and software-defined networking is something that you're really going to see hand in hand, because OpenFlow has been the most widely adopted protocol, even though there's 2 other ones that are out there, but you're going to most often see in industry the OpenFlow protocol adopted when organizations such as Google Cloud, or say organizations, but products like Google Cloud are adopting these technologies at this time. So what's so special about it? Software-defined networking simplifies network control and management through network programmability. What's cool about this is that it separates the control and data plane by transferring the network intelligence and state to the control plane. Before, with hardware-driven environments, all of that was baked in, and you really couldn't do much to alter the network intelligence on a hardware device. But with software-defined networking, it's really changed that space 100%. Gives you a lot more options, and obviously you can do more advanced applications of networking, such as the ones we're talking about, with a technology like software-defined networking. So, really, what does that mean? I like this plane decoupling picture because it shows essentially what's happening with a traditional hardware-driven environment, or I guess more, say, fully baked version of the different planes when it comes to a networking environment. With software-defined networking, it's basically decoupling those planes, where it's separating the data plane from the management plane and the control plane. So you're able to basically make that controller smart or programmable, and you can change that so whatever data it's working with, you're able to change that as you go. It's really kind of think about the fundamentals that if anyone's into something like DevOps, or even some of the newer API gateway technologies. I've been working with one at my job right now, Google Apogee. They're very much like the second photo at the bottom, where you have the logic in the control plane and it's separated from the data plane. And the gist of this is that network virtualization and automation is supported better by SDN than by traditional network architecture. So that just goes to show that the plane decoupling is more agile and more flexible than if you have, a kind of like one size fits all application of networking when it comes to your data plane, versus having a decoupled environment where you have a smart controller that you're able to work with as you need. So DSP in the cloud access network. So why is this important? Cloud access networks are essential for the cloud DSP paradigm. I like this photo on the right because it's showing what essentially that would look like in an architectural sense. I have this term up here, ROADM, or reconfigurable optical add/drop multiplexer. Obviously, long word, really what does that mean, right? So it's basically a network that can be reconfigured remotely if the network patterns change. So if you remember the last slide where I had the plane decoupling, obviously the second photo is where a network could be potentially reconfigured remotely, because the logic, the network logic, or even there's network operating systems that even exist. We're able to configure those things remotely and separately from the data plane in order to work with the environment in the way that you need it to be. The OpenFlow protocol also plays a very important role here, is that it enables SDM on a ROADM-based network. And that's really going to show what I mentioned before with the plane decoupling and the ability to separate the control and management plane from the data plane. So moving on to some industry applications. software-defined radio cloud, SDR cloud. So what does that look like? Potentially a set of distributed antenna sites that connect data centers through low latency and high bandwidth communication links. SDR and cloud computing technology processes digital data entirely in data centers, which makes sense, right? That's where the action's going to happen, right? SDR has wireless transceivers that implement a significant part of DSP and software that executes on general purpose hardware. So this is an application of digital signal processing in the cloud. It's a virtualized environment that's allowing the processing or the data transmission to be happening in software. Obviously, you're using wireless transceivers as well, but the software is doing the work. It's not being done in the hardware. It's using low latency and high bandwidth communication links, which I'll talk about in a moment. Obviously, that's also an interesting space that's tangential to making this a reality. So what are we seeing right now? And this is also quite neat. I guess I just moved to the Washington, D.C. area, and the area in Northern Virginia has a high concentration of data centers. So I've been kind of reading and educating myself a little bit more about that. The Google Dunant subsea cable was just completed, basically going from France to Virginia Beach. And it's a cable that leverages space division multiplexing technology to deliver 250 terabytes per second. That's pretty intense. There's a lot of articles, if you're interested in the space as well, that's discussing right now the battle between the cloud providers and your traditional ISPs like Verizon and Comcast, right? You have those folks that have their networks, they have their businesses and the way they run like an ISP. But the cloud service providers, the Amazons, the Googles, I'm not 100% sure what Microsoft has been doing. I haven't seen too much in the media about it, are building their own networks, and they're superior to what the ISPs are doing. Obviously, those organizations have the money to do it, but it's quite impressive the power of the technology that they're implementing. I mean, I talked about my time at Indiana University when I was in grad school and how it was really interesting to learn about software-defined networking at a time when it wasn't in industry, and thinking like, wow, 100 gigs per second, that's so fast. That's a drop in the, that's not anything to 250 terabytes per second, right? So what you're seeing is the cloud service providers are using their financial heavyweight and probably political clout, because it probably takes some economic, I want to say it, some schmoozing on their part to convince these local municipalities or governments to say, hey, like, we're going to build a subsea cable connecting our countries. We need to build the infrastructure. Do you want to say yes, right? So it's really interesting that a lot of this is happening now. Obviously, we're seeing all of these changes in general in technology. And I think the next ACM meeting is great because it talks about reinventing your career all the time. Because, I mean, this is just it's nothing but change, right? So I have two sentences up here on these slides that talk about modern communication networks are increasingly struggle to support the growing demands of emerging network services and traffic, including increased number of connections and ultra low latency requirements of 5G. So if you remember my slide before when I was talking about software-defined radio, ultra low latency and high bandwidth is what's needed to run an application like that. So something like this Google network would be something that could actually run that. Obviously, ISPs and even cloud service providers are challenged to offer multi-gigabyte connectivity speeds in a cost-effective manner, negotiating between traffic and revenue growth via subscriptions. So if you think about it right now, I don't know who your ISP is. I don't know what service subscriptions you have, but it's all either you're going to jump on that bandwagon or you're going to be old school and left, I don't say left behind, but how are you managing your digital assets on a personal manner is one thing, but if you're thinking about if you're leading an organization or you're leading an IT department, and you're trying to migrate everything to kind of the latest and greatest in cloud computing because you're trying to keep up with the times. Our ISPs and CSPs are essentially attempting to figure that out as well. Like, how am I gonna deliver this to my to my customers in the best manner where I'm going to be able to negotiate between traffic and revenue growth via subscriptions. So it's a quite an interesting space. It's not only a technological challenge, but there's an economic and business challenge in there as well. That we're working, depending on what you do on a daily basis, you might not be exposed to this, but this is definitely affecting many major organizations and kind of those technology heavyweights that we think about when we are thinking about technology companies. So here I have some more applications talking more about about cloud service providers. If you've ever seen the photo on the top right, that's essentially AWS's availability zones. I just like to show this because they are growing, obviously, and I think that between Amazon and Google, there's going to be an interesting, I guess, competition to see how the trajectory of those organizations and who's going to survive, and or potentially have either superior products or market share. But we're talking about networking. Amazon Web Services and Google Cloud are essentially leveraging virtual private cloud, or VPC, for software-defined networking functionality. What Google uses, and there's a really sweet white paper on it that's out there for consumption, is their VPC is what they call Andromeda, where you have the virtual machine controller, or VMC, that uses a combination of OpenFlow, that protocol that I keep bringing up, and proprietary extensions. So you see on the lower right-hand corner, very similar to some of the other graphics that I've been discussing as well, is that you have the VMC on a different plane, in the control plane and management plane, and you have an OpenFlow front end, and you have the host switch or layer on a different plane, or potentially on the data plane. Amazon's also using a VPC, and essentially they have a network layer baked into EC2, which is their compute product, that allows for elastic interfaces and IPs, which is very similar to the functionality I was talking about before when it comes to network virtualization and automation. They're able to be flexible in what they're delivering when it comes to networking. Just like Google, they both have a somewhat decent kind of third-party marketplace when it comes to software-defined networking partners. So you don't have to go with their platform. You can definitely integrate with another network provider, but they do have these built-in technologies to utilize if you wish. So I know we have a few minutes left here. I wanted to maybe open up for what's next or any questions. I have some items for discussion as well if we want to explore them. But I've been doing all the talking, so maybe we can open it up for questions or conversations or something I missed. I guess I'm open. I was articulating that, I had a lot of theory in my slides. I wanted to bring up something that shows the real world application of what I was talking about. So if you haven't seen this is a neat project to look out called Google Magenta. And it's basically leveraging different types of technologies that you might have seen, such as Python, TensorFlow, JavaScript, in addition to other technologies, and showing you different applications of DSP and cloud computing. This is one called MusicVey, a machine learning model that lets you create palettes for blending and exploring musical scores. looks as simple as a MIDI scroll going on here, right? I'm trying to find a better part of the video here. The other one I wanted to bring up, I mean, obviously there's a lot of examples here. Let me bring up this other one that I thought was, so I don't have a MIDI keyboard set up here, but what I can do is, this is called DrumBot, and basically what I can do here is record. This is not sophisticated, right? When you think about it, you have a MIDI keyboard, you can probably do a lot more. And when I was playing with it before, it starts putting in drums automatically to what you've played. Oh, I didn't do it this time. But there's a lot of different applications on that link. You can definitely go and explore as much as possible. This one is similar to the first one that I had, where right, it's low latency happening in real time. I have, you know, a very basic, I don't have fiber internet where I am, and this is still coming back somewhat quickly. So yeah, just kind of interesting. This has come a long way. If you don't know a lot about this space, this is actually very kind of cutting edge, so to speak. So obviously quite interesting in that, you know, you might think it looks simple, or, you know, this reminds me of my Casio keyboard from, you know, 1992. But at the same time, this is actually coming a long way computationally, and from a user point of view as well. You know, anyone can access this from anywhere. It's not only you know, tied to a computing environment in like a classroom per se.
We can get some questions. So maybe Mark, you can moderate for any questions that any people have.
From Martin O'Shield, when will your next outstanding presentation coming back to the Chicago ACM?
Oh, that's nice of you.
Technology sincere in Chicago. That's my question only.
Yeah, I don't know. I love you know, presenting on topics. I have to think of something else that I could do. I mean, this is something that I have experience in, and I'm, you know, kind of passionate about it as well. So I'm not sure. I have to find another topic. I'd probably do it on the Google networking, because that stuff is super interesting as well. The subsea telecom cables. I'll come back. I still own my condo there, so I'm sure I'll be back.
Maybe you can come in person.
Yeah. Mm-hmm.
So I have a question, but I also want to ask before that question. So what we were hearing, as opposed to in the past, you'd say, well, that sound's coming from their computer, but this sound was actually being generated in the cloud as we heard it, correct?
Yes.
Okay, well, that's really different.
It is
to 5 years ago.
To the layperson. You know, I guess that's what I'm saying. Like, sometimes the layperson or somebody who, it'd be like, what's the big deal? But it kind of is a big deal, right?
So my question is, from your view, do you think that this is changing the way that existing musicians and composers might work? Will it change them now, or is this really a different group of persons that have yet to arrive?
Yeah, I mean, when I went through grad school, when several years ago when this was sort of futuristic, kind of, is that real? People were already collaborating using internet too. Some of the professional orchestras, like the New World Symphony, New York Philharmonic, Chicago Symphony Orchestra, I think as well, had been leveraging Internet 2 technologies for quite some time to do virtual low latency communication. When I worked at DePaul University at the music school, I actually engineered a masterclass between Chicago and Florida for the percussion studio, just to do it right. And it wasn't really part of my job description, but that was maybe in 2010, where you have in 2015, obviously people are collaborating in the music world via social media, file sharing platforms, YouTube, right? Like the remote collaboration has been happening, but maybe not necessarily in real time, just because the technology wasn't there. It was all kind of like, hey, I did this, I'm sending it to you. You can upload it in your digital audio workspace, or do whatever you want, manipulate the media and send it back to me. Or there was latency issues, and actually my department at IUPUI, they've been developing plugins to deal with the latency, so when musicians are collaborating over networks, that it's minimizing that latency. However, with cloud computing and the way that things are evolving, all of those other things are kind of going to be thrown by the wayside, where it's going to be real time, more accessible. I think, at least, from what I've seen and the musicians that I'm still connected with, the ones that are progressive are definitely embracing new technologies like this. They're embracing things like machine learning. I was at the talk by Sam Pluta a few months ago. That was great. He's in the batch of those kind of progressive musicians that I see embracing new technologies. If you want to stay relevant, I know that young musicians and artists are being taught you have to deal with technology, otherwise you're probably not going to be a successful artist, just the way that the space is going. I think it's also opening up as well for people, for hobby musicians, and people just kind of do it for fun, or maybe a side hobby as well. They're able to get tools at a cheaper price. If you think about the history of the recording arts world, you used to have a budget, and you have to go into a studio that had $150,000 worth of equipment and a console, and you had to hire specialized engineers to operate it. But now everything is basically in your MacBook Pro that you can buy from the Apple Store for $1,200, right? So that whole space has changed, and it's changed the way that people are collaborating and making music. And I think cloud computing is just making that more accessible to the masses.
Right. That's great. Great answer. We just have to make those Neumanns and AKGs more available.
They're getting modeled more and more every day. I always see a new piece of gear now as a piece of software. So it'll be interesting to what happens with the. I'm surprised I'm sure there's got to be some sort of microphone modeling plugin out there.
In case people missed on that, the microphones, still the really good ones, are still very expensive, but they never lose their value. That's one of the unique things. It's a technological item that keeps its value.
Really cool PhD dissertation to make a microphone plugin.
There you go. Any students who are going to do a PhD, that's one possible
That's what I would do.
thesis topic.
It sounds like something I would do if I had money to do it.
Okay, our next question is from Yunpa Chai. Hopefully I got that name right. Are there any sites on long, short-term networks applications to composing music with machine learning?
Not that I'm aware of. I think that space is very much like tied to some of the major cloud service providers, as I was talking about. The closest thing that I saw to that is what I pulled up with the Google Magenta. But as far as like dedicated networks where that's happening, that's usually either like set up private at a university, or there's different software plugins that are available. And there's one that was evangelized when the pandemic came out. It was made by Stanford University, and maybe I can follow up with Mark and Alan. But there was actually a piece of software to help people do just that, but on their MacBooks at home or their PCs. So not really on a bona fide like subscription. You have like platforms like Splice, but that's almost like a personal branding / production network where it's more rooted in almost like a social media aspect of it. So when you think of a network like that, that does exist, but that's going to be different than like, I'm creating my own network. Let's say I wanted to be in a band with Mark and Alvin, and I wanted to jam with them in real time. We'd all have to have that plugin running to create our own private network.
But she also mentions that she read an article on LSTM network applications to synthesize music on Medium or towards data science. And so she thought it might be relevant because of the mix of random probability and musical logic applied to write music. And
Yeah, I'm not familiar
thanks.
with that one. I learn something new every day.
Yeah. And you mentioned also, so I remember that was a kind of a well-known secret about Internet 2 about 10 or 15 years ago. Is it still with us, or was it an experiment?
Yeah, Internet 2 is still with us. It's been upgraded. I forgot the new speed, but it's still there. Obviously, it's not open to the public like the cloud service providers and that technology that I've been talking about. But it is still there and available. But, I've been a part of, startups and now corporate environments where I'm doing the upgrading in that department. So I don't get to hang out in those cool environments anymore because I'm not in a academic environment or maybe in a data center. I don't. It'd be interesting. I was just talking about how I think outside of Silicon Valley, Northern Virginia has no, not outside of it. They do, and I think in the United States have the highest concentration of data centers. But I don't work in data centers, so I don't know what that looks like or even what kind of bandwidth those facilities are leveraging. That's why I said if I did another presentation, I would probably do it on that because I find that space super interesting.
And here's a question from Martin O'Shield. Can you give us a little more detail about the ability to have private conversations if you have a 5G enabled handset?
You mean like you don't want to get hacked and someone to listen in on your conversation? Or is it like, I guess I'm trying to realize I'm trying to figure out an application of the question. Like if I'm talking on my phone, which is 5G, how do I make that secure?
Right. Maybe we can have Martin ask this. But he said, and when you return for your next outstanding presentation, would you please walk us through some fun DSP cloud stuff we can access remotely from wherever we are?
Yeah, that Google Magenta application is one of the best ones out there that I've seen. That's why I pulled it up.
Okay.
I did not build anything from scratch. I haven't had time.
I'm available for a quick question if I can follow up.
Oh, great.
Yeah, sure. Go ahead, Martin. Yeah.
Cool. Yeah, thank you. Excellent presentation. I'm highly impressed. But you have to come back, young lady. You do. But you had stated earlier in your presentation something with regard to if you have 5G enabled chips or something enabled in a chip that you're able to directly communicate or network with other people that had that ability, had that chip, or
the Elk Audio product.
Okay. Mm-hmm. Okay, excellent. Thank you. I'll look that up and learn more about it. But thank you very much for tonight's presentation.
Yeah, it's audio over IP protocol. So
audio
it's like,
over IP. Okay.
Yeah, audio over IP, but it's using the 5G chipset, and then you can, Elk Audio is the company that's doing it.
Excellent. Thank you so very much.
You're welcome.
Thank you.
Okay, are there any other further questions?
Well, I have an old story I can tell. So back in, I think it was 1990, and I was taking a break from playing. I was playing a long run. I was playing Les Miserables, actually, in the pit at the Auditorium Theater. And I took a break and I went off to visit a friend in Pittsburgh. And I went to the computer music lab at Carnegie Mellon University. And I saw there Roger Dannenberg, who is one of the most amazing computer scientists that I've ever met. And he had an application that would listen to someone play and accompany them. Now, these were all preset accompaniments, but it would actually follow your timing. And so I tried to do things like drop beats, drop bars, skip repeats, make an extra repeat. You couldn't shake this off. It was amazing. It was running on an Amiga computer at the time. And that became the product and Finale's accompaniment product. I can't remember the name of it. So it was totally amazing. And of course, that was 40 years ago, right? 30 years ago.
Yeah.
But there's certainly music and audio has been one of the great areas for technology.
Yeah, it's super interesting space. Definitely something that I've pursued just because it's, I don't say somewhat unique, but you think about how you have a relationship with computing and technology in your life, and those are very humane aspects of the application of technology. That's just not like, oh, well, this is my microwave or this is my phone, right? It's a more unique application of technology, which now, especially with things like digital transformation and data science, those things are becoming more common, where before I don't think people cared as much. I think smartphones and wearables have changed a lot of that. Obviously, things like the pandemic. We also live, I feel like, in a society where you're trying to do more with less in all of our jobs. Things are getting automated. We're not a manufacturing-based economy anymore. We're globalized. So technology is, and especially unique applications of technology to solve problems is a part of our daily life more so than it maybe was 20 years ago.
Okay, great. So thank you, Teri, for the wonderful presentation, and for thank you all for the questions. I already launched the poll, so we'd like to get your feedback regarding about this meeting. So I've seen some people already here have voted, so that's really, really great. Just to reiterate, our next presentation from the IEEE Computer Society is next Wednesday, and it's on secure sourcing of commercial off-the-shelf products. And like I said, we have our distinguished lecturer from IEEE Computer Society, Dan Shoemaker, and you can register at this bit.ly/IEEE Chi CS 0621. And then, of course, we have our next presentation or panel discussion that we will have in July. So maybe, Mark, can you just maybe repeat that?
Sure. Remember that this presentation features you, the audience. We're going to really want everyone who wants to put in their view, 2 cents, whatever, to contribute to this talk. And we're going to know soon who our panelists are, but if you look back at some of our presenters over the last few years, don't be surprised if you see some of them there, and they'll be able to add their perspectives on these same questions. And for those of you that are still here, I'd like to add also that we are also looking for more people to join the board. There's a lot of things that we could do here with this group. And I just want to add that I think that what's really helped me in my own career changes over the last 2 years are attributed to 2 things: being on the ACM and teaching. And because of those 2 things, I've improved my communication skills speaking and writing greatly. And in this last year, I've expanded to adding Premiere editing, video editing, audio editing, things that I always wanted to do. And it wasn't that I didn't have time. I still don't have the time, but I do it because there's the opportunity. And so things like that, going out, researching topics, finding speakers, it's a great way to network. You know, by finding a speaker, you might be actually finding the next place that you want to work at. So these are, I'll bet that these are skills you can't develop much at your present job because we just don't get those opportunities. They want us to do the work that they hired us for. But if you want to move up and develop, having these communication and multimedia skills and probably other things that I haven't even thought of are really valuable. And I'll just say that the ACM is a great place to develop those things and to have them noticed.
Yes, definitely. That's exactly correct. I mean, for me, you know, volunteering is really great, and especially, you know, if you want to make an impact. I think the key thing here is that if you want to really make an impact on the community and the industry, then this is the way to do it by volunteering. So please, if you have some time, think about it. You can reach us at vicechair@chicagoacm.org or chair@chicagoacm.org. And if you have any other questions, you know, about what type of volunteering jobs or what stuff you want to do, you know, just feel free to reach us. I mean, we are always in need of other people, so it doesn't matter what type of skill set you have or so. I'm sure we can be able to make use of your talents in a very, very good way. Okay, so we're at 7 o'clock. So thank you everyone for attending our kind of official last meeting of the year before the summer. So thank you all for staying with us during this year virtually, and hopefully the coming year in September we'll be able to attend in person, but we'll let you know. And wish everyone a happy summer. So thank you everyone for your support of ACM Chicago, and hopefully we can be able to see you at a future event, either virtually or in person. So like I said, the recording of this talk is going to be made available, plus the slides from Teri and the slides for the introduction. As well, for those who need a professional development hour certificate, that will also be made available too as well. And of course, you know, be sure to follow us on social media.
Thanks,
all right.
Thanks, Teri.
So thank you, everyone. Thank you, Teri.
Thank you.
Bye.
Enjoy the summer.
Enjoy the summer, everyone. Take care.
Bye.
Stay healthy and safe as
You
well.
too. Bye.